The most expensive stuff in the universe! Yeah, grandiose. Is called antimatter. Its existence was first theorized in 1930 when the electron was discovered. Scientists thought it might mean the exact opposite should exist too, and they called this hypothetical particle positron. Later, antipodes of other elementary particles, protons and neutrons, were proven to exist as well. Morons came later. When a particle and its evil twin collide with each other, they disappear, releasing literally tons of energy, 10,000 times more than a nuclear reaction does. But there's a catch. It takes about 100 billion years to create just 1 gram of antimatter, and it can only be created using the Large Hadron Collider. That's why the cost of this substance is about 62 trillion bucks. And we're not even close to getting that much. Throughout the entire history of space observation, only 2 objects from another star system, or maybe even another galaxy, have entered our solar system. The first one was the Oumuamua asteroid, discovered in 2017. The second was Borisov, a comet found in August 2019. The cloud of dust that surrounds it allows scientists to learn more about substances that may have come to us from another galaxy. An unusual teardrop-shaped star was found. It has almost twice the mass of the Sun and looks like a big drop of lava because of the dwarf star hanging out nearby. The little buddy attracts the energy of its big brother and distorts its surface. Black holes can do that too. There's a star about 215 million light-years away from us that got spaghettified because of the gravity of a black hole nearby. Astronomers on Earth had to use dozens of telescopes to register the event. In the end, they saw a black hole gobbling up a star, which stretched until it became a thin ray of matter. As it was eating, the hole also ejected billions of tons of star material into space. About 250 million light-years away, though, there's a miraculous survival story. In 2020, a red giant came too close to a massive black hole, 400,000 times heavier than the Sun, and got caught in its gravitational pull. Normally, this means there's no escape. Once a black hole catches something, it will never let go of its prey. In this case, the star somehow managed to get away. Most of its outer layers were slurped away by the hungry black beast, leaving behind only the molten core, a white dwarf. And using this loss of mass, it ripped itself from the black hole's tug and started circling it at an ever-increasing orbit. Scientists are sure the white dwarf is still imprisoned forever, though, because the hole continues to chip away at it even as it gets further. In the end, the star will cool down and become a planet that looks much like Jupiter. But that might only happen in about 1 trillion years. I won't be around then. And much longer than the universe has been around so far. It was proved that a planet can orbit a black hole as it would a star. The energy from the hole would feed such a planet. But to survive in such conditions and not be pumped inside the event horizon, the planet must orbit very quickly, at nearly the speed of light, and the black hole itself must spin at the same speed. I can't but imagine what kind of life it would be on such a planet. Fast? Earthquakes on the moon, or shall I say earthquakes, aren't something from science fiction. They don't occur as often as on our planet, and when they do, it happens closer to the center of the satellite. Scientists think moonquakes might be caused by the gravity of Earth and the Sun. There are Marsquakes too. For a long time, the red planet had been considered tectonically inactive, but more recent observations have shown it still has weak quakes from time to time. You probably wouldn't even be able to feel them if you stood on Mars' surface, but it means some geological processes are still going on underneath the red and dusty landscape. At a distance of 640 light-years from the Sun, scientists discovered the planet WASP-76b, where it rains iron. The planet is very close to its Sun and always turn to it with the same side. The term is tidally locked. The temperature on the sunny side is so high that metals melt and evaporate there. The other half of the planet is cool enough that metals condense again and fall down as rain. Speaking of tidal locks, our moon is the same way. There's no dark side to our satellite, it's just always turned to us with one side. When the moon happens to be in between the Earth and the Sun, what we call its dark side becomes brightly lit. We just can't see it from our planet. Figures. Turns out there are plenty of planets in the universe, and even in the Milky Way galaxy, that have liquid or frozen water on them. The closest one is within our solar system. It's Europa, one of Jupiter's moons. Scientists are almost sure that underneath its frozen surface, there's an actual ocean of water. But it's too soon to be hyped about possible life on other planets. Liquid water is only one of many things that have to come together for life to appear on a planet. In fact, there's a place millions of light years away where there's a whole floating space cloud made entirely of water. There's so much of it that it could fill all of our oceans 140 trillion times over. Slightly more than what we need. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance thanks to which we can now thrive. But in space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water it would be enough to fill our oceans 1,000 times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth not only thanks to fossilized remains of living beings, but came from outer space as well. And yet, there just might be about 6 billion Earth-like planets in the Milky Way galaxy alone. The latest data has shown that every fifth Sun-like star can have at least one planet in its habitable zone. And not just any planet, mind you. It has a rocky core and surface, and it's of a comparable size to the Earth. Being inside the habitable zone of a star, such a planet would have high chances of becoming home to living creatures, microbes at least. And if there are billions of these planets in our galaxy, you could safely say that at least one of them is not only inhabitable, but inhabited already. And now multiply this by the number of galaxies in the universe, also considering that many of them are much bigger than the Milky Way. This gives us billions upon billions of Sun-like stars and Earth-like planets, and some of them are surely more like ours than others. Until recently, we thought our galaxy looked like a circular spiral. But recent research has shown it looks more like a Pringles chip. Scientists measured the distances between the Sun and other stars and created a three-dimensional map of the Milky Way based on this data. It turned out that our galaxy is slightly curved at the edges and takes an S shape. At this, we might be able to walk upright because of supernova explosions. About 2.5 million years ago, a supernova sent cosmic rays to our planet. They triggered a series of electrical storms in the Earth's atmosphere, which turned into thunderstorms. Those, in their turn, caused wildfires in northeast Africa, where our earlier ancestors lived. Fires turned the forest area into a savanna, the atmospheric pressure changed, and our ancestors had to stand on two legs to survive. The biggest explosion since the Big Bang was registered in 2019. This happened in the Ophiuchus cluster, which unites thousands of galaxies. According to scientists, the blast was equal to 20 billion, that's 18 zeros, megaton explosions happening once a millisecond for 240 million years. I'll have to trust that. My math is not that good. Remember the asteroid that wiped out the dinosaurs on Earth? Who could forget? There might have been another space show that ended badly for at least 75% of all life on our planet in the past. Roughly 360 million years ago, a supernova explosion occurred about 65 light-years away from us, and the cosmic rays sent by it swept away the ozone layer of our pretty blue ball. If it had been any closer, all life could have easily been gone. Right now, the greatest threat for us comes in the form of Betelgeuse, not the movie, but a giant star about 600 light-years away. If it explodes into a supernova, We'll see it with unaided eyes even during the day. Solar eclipses are cosmic magic tricks during which the moon suddenly swallows the sun. Only they work not on magic, but on simple science. Let's try to find out how exactly they work and how you personally can observe this fascinating event. It all starts when the moon, the sun, and the earth line up in a straight line, with the moon positioned directly between us and our favorite star. This alignment is possible because the moon's orbit around the sun is slightly tilted relative to the Earth's orbit around the sun. Solar eclipses only happen during new moons, when the moon is closest to the Earth in its orbit. So, when the alignment is just right, the moon's shadow is cast on the Earth, blocking the sunlight from reaching us. Imagine being in a room with a giant light switch, but instead of turning the light off, you just cover it with a big old moon. That's basically the solar eclipse. Solar eclipses aren't a regular occurrence, and they only happen a few times each year. The frequency of solar eclipses is determined by many things, like the alignment of the moon, sun, and earth, and by the position of the moon in its orbit around the earth. Now, there are three main types of solar eclipses: total, partial, and annular. A total solar eclipse occurs when the moon completely covers the sun's disk, and the sky becomes dark as if it were nighttime. This phase can last for a few minutes to just over an hour, depending on the distance between the moon and the earth at the time of the eclipse. A total solar eclipse can only be visible from a specific region on the earth called the path of totality. This path is typically a narrow strip of land or sea, and if you happen to be exactly in the right spot, you'll be able to enjoy this wonderful view. Unfortunately, not everyone is so lucky to get to see a total solar eclipse. Sometimes the moon only covers part of the sun. In that case, you'll see a crescent-shaped sun instead of a completely swallowed one. That's called a partial solar eclipse. And if you're really unlucky, the moon might be too far away from the Earth to completely cover the sun. In that case, you'll see a bright ring of sunlight around the moon's silhouette. That's called an annular solar eclipse. Solar eclipses are some of the most spectacular celestial events that we can observe from Earth. People have observed and studied them throughout history, and they've played a significant role in our understanding of the sun, moon, and Earth. For example, we use them to measure the size and distance of the moon and the sun, to study the solar atmosphere, and to test Einstein's theory of general relativity. Solar eclipses have always been important to people, so it's not surprising that they've always been connected to different myths and superstitions. Some cultures saw them as a sign of dreadful things to come, or a way to talk to their deities. Others thought they could be used to predict the future or scare away evil spirits. All these beliefs show how much solar eclipses have meant to people. There have been many fascinating and memorable solar eclipses throughout history, each with its own unique story or significance. Here are a few examples of some of the most mysterious, cool, or just famous solar eclipses. The eclipse of Thales is one of the most famous solar eclipses in history. It's said to have occurred in the year 585 BCE, and it was reportedly predicted by the ancient Greek philosopher Thales of Miletus. According to legend, Thales was able to predict the eclipse by observing the cycles of the moon, and his prediction is said to have amazed and frightened the people of the time. The eclipse of Ptolemy was a total solar eclipse that's said to have occurred in the year 150 CE. It's famous because it's mentioned in the writings of the ancient Greek astronomer Ptolemy. He used his observations of the moon's cycles to make his prediction, which astonished and alarmed people of that time. The eclipse of the century was a total solar eclipse that occurred on July 11, 1991. It was visible across a substantial portion of South America. It was the longest total solar eclipse of the 20th century, lasting for more than 6.5 minutes. The eclipse of the pyramids was a total solar eclipse that occurred on March 20, 2015, and it was visible from parts of Europe, Africa, and the Middle East. It got famous because it passed directly over the ancient pyramids of Giza in Egypt, providing a unique opportunity for scientists and tourists to study the eclipse from this historic location. And, of course, the Great American Eclipse of 2017. It was a total solar eclipse that was visible across a large portion of the United States from coast to coast. It was the first total eclipse visible from the contiguous U.S. in nearly 40 years, and it attracted millions of spectators and was widely covered by the media. Since they happen quite rarely, you wouldn't want to miss such an event. Fortunately, we have a calendar of solar eclipses that will occur in the next few years. The Great North American Eclipse of 2023, expected to be visible in a substantial portion of North America from the Pacific Northwest to the Great Lakes region. It will be the first total eclipse visible from the United States since the Great American Eclipse of 2017. The Eclipse of the Andes of 2024. This one is expected to be visible across parts of South America, including parts of Chile and Argentina. It will be the first total eclipse visible from South America since the eclipse of the century in 1991. The Eclipse of the Arctic in 2025. This one will be visible in the Arctic part of our planet, including parts of Canada and Greenland. It will be the first total eclipse visible from the Arctic in nearly 100 years. And the Eclipse of the Pacific in 2026. This eclipse will be visible across parts of the Pacific Ocean, including parts of Australia, New Zealand, and the United States. It's worth noting that the exact timing and visibility of these solar eclipses may change as more precise predictions are made. Also, some other solar eclipses may also occur in the coming years. Don't forget to check the details online. But the most important question is, how do we watch them? The answer? Very carefully. Here's some general tips. Use proper eye protection. Never look directly at the sun, even during an eclipse. It's not worth risking your sight. To observe a solar eclipse safely, use things like certified solar eclipse glasses or a pinhole projector. These devices allow you to view the eclipse without looking directly at the sun, and they help protect your eyes from the harmful effects of the sun's rays. Find a good viewing location. To get the best view of a solar eclipse, it's important to find a location that is within the path of the eclipse and has a clear view of the sky. Use a camera or telescope. If you have a camera or telescope with a solar filter, you can use it to take pictures or observe the eclipse more closely. Just be sure to use a solar filter to protect your eyes and equipment. Stay informed. It's important to be up to date about the details of a solar eclipse, including the exact timing, location, and type of eclipse. This information can help you plan your viewing and ensure that you have the proper equipment and safety precautions in place. That's it. Simple, isn't it? By following these tips, you can enjoy observing solar eclipses safely and responsibly. And if you do get to see a solar eclipse, make sure to snap some pics and share them with your friends. Remember, it's a once-in-a-lifetime experience after all.
We're traveling through space at the speed of light. The route from Earth to the Sun at that speed will take only 8 minutes, but it would take us about 35 years to reach our destination, which is, by the way, still very fast. By comparison, a conventional rocket would take about 600,000 years to make the journey. And here we are. It's a star system suspiciously very similar to our own. And our scientists suspect that life could exist here, just like on Earth. A red dwarf, 30% the size and weight of the Sun, lies at the heart of this star system. But these are the planets orbiting the star that interest us most. The first of these is L9859b. Its size is somewhere between Earth and Mars, but it's very light. It's only half the mass of Venus. But life is impossible on this rocky planet. It's too close to the star, and it's so hot, you'd burn a cake if you tried baking it on its surface. It's about 100 degrees higher than the maximum of your oven. The planet makes a complete circle around its host star in just 2 days, compared to 365 for Earth. And it gets 22 times more energy than we get from the sun. So it's not only hot there, but there's a lot of dangerous radiation. The next planet is 2.8 million miles from its host star. That's 13 times closer than the distance from Mercury to the Sun. And it makes a complete revolution around the star in 3.7 days. But what's interesting is that the planet is 30% bigger than the Earth and twice as heavy. So it belongs to the class of super-Earth planets. Such planets can be rich in water ice, methane, and hydrogen. These are some of the elements that are necessary for life's existence. Many scientists believe that it's on such planets that extraterrestrial civilizations can live. But because of the great weight of the planet, it has a strong gravitational force. So these civilizations may not be able to fly into space because it's harder for them to get out of the gravitational trap of a super-Earth planet. However, life isn't possible here because the planet is still too close to the host star. And just like in our solar system, the two nearest planets are too hot. But the third planet looks more promising. L9859d. It's almost twice as heavy as the Earth and 50% bigger. Scientists have calculated that about a third of its mass could be water. For comparison, the mass of all water on Earth is only 0.02%. The presence of water is the main condition for the emergence of life. But we can only guess where the water might be. It could be on the surface, but high temperatures can turn large oceans into giant clouds of steam. But water can also be contained in the groundwater below the surface. Well, we can't know that for sure yet. Let's move on to the next planet in the star system. This newly discovered planet is of the Super Venus class, L9859e. It's a rocky planet 3 times the size of Earth. The Super Venus class means that the planet is heavy enough to have an atmosphere, but the conditions there are more like a greenhouse. Different gases fill the atmosphere there. Star rays pass through them to the planet's surface, reflect off it, and rise upward. But the dense gases don't let them leave the atmosphere, so the planet gets hotter and hotter. This is the greenhouse effect that we try so hard to avoid on Earth. On top of that, the stellar wind carries water vapor and other elements from the upper layers of the atmosphere into outer space. Life cannot exist on such a planet, nor could it ever originate, just like on Earth's twin sister, Venus. So far, all the planets we've looked at are outside the habitable zone of the host star. That's the sweet spot at a perfect distance from the star. Not too close so that the planet isn't too hot and the water there doesn't evaporate instantly. And not too far away so that the planet doesn't look like a cold desert. And planets B, C, D, and E are too close to the host star. But there's another hypothetical planet F in this star system, located right in this sweet spot. This super-Earth candidate is 2.5 times heavier than our home planet. So we have hopes that it's a rocky world, just like the other planets in this star system. The weight of planet F is enough to have a dense atmosphere, and the temperature on its surface should be suitable for water to exist there in liquid form. The planet makes a complete circle around its host star in 23 days, which literally means it's New Year every 3 weeks. It isn't very likely, though, that there's a civilization there that celebrates it. Indeed, the very existence of this planet is very doubtful because we still have no direct evidence. All the other planets have been discovered by the transit method. That's when we point our telescopes directly at a star and watch its brightness change. When there's a slight drop in the star's brightness, that's when a planet has passed between us and the star. Like this dot. We have a short period of time while the planet is in the background of the star to determine its size and speed. Sometimes we can observe such transits of Mercury and Venus on the solar disk. And there are at least 29 potentially habitable planets out there in distant space that can observe Earth in the same way. About 1,715 stars within a few hundred light years are perfectly located for it. Each star has planets around it, but only 29 of them are in the habitable zone. So there really could be life and an intelligent extraterrestrial civilization out there. If so, they could point their telescopes toward the sun and see a small dot pass across the solar disk. And they could have been making these observations for at least the last 5,000 years. So they could see how our civilization was born and how we evolved. Moreover, these planets are close enough to pick up our radio signals and even television broadcasts. But it works both ways. Radio signals travel through space at the speed of light. We mastered this technology about 100 years ago. So if there really is a civilization out there somewhere, we would pick up their signals too. But so far, it hasn't happened. So we have no proof of the existence of life on these planets. The discovery of a star system like L9859 is very important to us because we're always looking for life outside of our solar system. And super Earth-class planets are even better suited for the origin of life than planet Earth itself. Such planets are sometimes called super-habitable. So some scientists think that Earth is a good place for life, but not the best. Super-habitable planets would have to be 30% larger than Earth and twice as heavy. This would create stronger gravity, which would make the atmosphere on the planet denser and with a higher concentration of oxygen. This in turn would raise the average temperature on the planet to a perfect 77 degrees Fahrenheit, so plants would thrive there. Also, stronger gravity makes the surface of the planet flatter, so there might be more oceans there than on Earth. This would make aquatic life much more diverse. The host star also plays a very important role. It should be smaller than the Sun. The bigger the star, the more of its fuel it burns. This means that the lifespan of such stars is much shorter. For example, the lifespan of the Sun is about 10 billion years, but a red dwarf can live up to 30 billion years. More time, more opportunity for the birth of life and evolution. So far, scientists have discovered 24 superabundant planets, but that still doesn't mean that there is life there for real. But some scientists believe that there are already at least 36 advanced civilizations in our galaxy, besides Earth. They've searched for similar worlds on the star map. First, we find stars that look like the Sun among about 100 billion stars throughout the galaxy. Now we choose from them those that are rich in iron. Such stars burn at the perfect temperature and help the planets around them gain an iron core and become Earth-like. Now let's pick relatively young stars from this pile, because when they get older, they expand and either absorb the planets around them or burn them up. One last thing, let's find planets in this pile that are in the habitable zone of the star. And voila! 36 worlds may be inhabited by some unknown civilization. But we won't know for sure until we get in touch with them.